All right, we are on 7-2A. All right, so in 7-2A, the idea is that we're going to be understanding point-slope form. Okay, so what we need to know today is we need to make sure that we understand the slope formula, and then we're going to derive, which means we're going to try and come up with the point-slope form. So you don't know what point-slope form is yet. We're going to get there. But we do need to know the slope formula, the y2 minus y1 over x2 minus x1. We're also going to be doing rise over run today. Just all of it, all at once. It's going to be so great. Okay, so first we're going to find our slope between A and B. So on a graph, we're going to do rise over run. I should do this in a different color. So here's my A, here's point B. So first locate them. Then rise means to follow those lines in the background, go straight up, straight over. So how many does it rise? It rises up 1, and then it runs over 1, 2. So my rise was 1 and runs over 2. Question is, can I simplify this? If we're not sure, we can use Desmos. 1/2. And fraction, nope, it just stays 1/2. Okay, now we're going to do points B and C. I'll do that in green. So B to C, I'm going to rise up, make kind of a staircase. 1 isn't enough because if I go over, I won't get to C, so I have to go up again. And then straight on over. Okay, so this time it goes up 1, 2. So my rise is 2. My run is 1, 2, 3, 4. So 2 over 4. Most of you, I think, can look at that and know. If you're not sure, though, if we make a fraction 2/4, it gives us the same handy-dandy 1/2. It simplified it for us. So remember, simplify means we can divide top and bottom by that same number. So they divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Interesting. Okay, then we have points A, C. So between A and C. So I'm going to do that in blue this time. So I'm going to actually go over and then up, but when I count, I want to think that rise first, because that gets a little confusing. If you went the other way, that's fine too. I just was trying to make it look less crazy. So my rise is this guy here. So it rises up 1, 2, 3. And it runs over 1, 2, 3, 4, 5, 6. Okay, so when we simplify this, what can we divide top and bottom by? Well, I can divide top and bottom by 3 here. So 3 divided by 3 is 1. 6 divided by 3 is 2. 1/2. Weird. They're all 1/2. What do you think A and D is going to be? If you guessed 1/2, your prob's right. If you guessed something else, I don't know why you would guess anything else. You're crazy. Okay, so I'm starting at A. We have to rise all the way up to D. Really important you try and stay on that vertical line. Don't go to the next one. And then all the way over. We have to be really careful when we count this. All right, it goes up 1, 2, 3, 4, 5, 6. And it's going to run over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6/12. I could divide top and bottom by 3. I could divide top and bottom by 2. Or I could just divide top and bottom by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. Whoa, they're all the same. So in order for 2 points to be on the same line, they have to at least have the same slope. So all of them have to have that same slope 1/2 in order for all of them to be on the same line. So here's the question. Are these 3 points on the same line? Okay, in order to know that, we need to do our slope formula. So we're going to take y2 minus y1 over x2 minus x1. Okay, and we're going to first start with -3, 5. We'll start with the first two, -3, 5, and -10, 14. Okay, so in that, my second y, remember it always goes xy, xy. I have to kind of do that curly Q on my y, otherwise sometimes my x's and y's look the same. Okay, so my second y is 14 minus my first y is 5, over my second x is negative 10, minus my first x, negative 3. And I do need in that negative. It's nice if we put that in parentheses. Negatives get kind of like some hugs. They just get parentheses. They're nice and comfortable. Okay, so 14 minus 5 is 9. And negative 10 minus negative 3. Whoops, that's not what I wanted to hit. My bad. Negative 10 minus negative 3 ends up being negative 7. And then remember that negative, we just don't like it on the bottom because no one says 9 negative 7ths. We just say negative 9 sevenths. So it goes to that top. Okay, so that's the first slope. Now let's do the second 2 points. So now let's do 10 and 14, negative 10, 14, and 11, negative 13. So we're going to take negative 10. We are not going to take negative 10. We're going to start with y2. My second y now between these 2 points is negative 13. So negative 13 minus my y1. My y1 is 14. Over my x2, so my second x is 11, minus my first x. My first x is negative 10. And we're going to see, does that equal the same thing? I have no idea. So negative 13 minus 14. Ooh, that negative 10 likes hugs. All right. Negative 13 minus 14 is negative 27. And 11 minus negative 10 minus, then we can put parentheses in negative 10 is 21. Positive 21. Well, those definitely don't look the same. Let's just double check to see if we can simplify that. So negative 27 over 21. Negative 9 sevenths. Why do I keep doing that? Negative 9 sevenths. So those are the same. Let's double check between these first and last ones. So I'm going to try and use my highlighter to show you that we're doing the first one and the last one, but I don't really know how to do that. So we're going to do this one and this one. Alright, so on this one we start with our y2, which is negative 13. I'm going to write it kind of here because I'm running out of space. Minus my y1, which is 5, over my x2, 11, minus my x1, negative 3. So that negative 3 gets some hugs, it gets some parentheses. Just needs some extra love. Sometimes everybody needs some extra love. So negative 13 minus 5 is going to be negative 18. And then 11 minus negative 3. Little hug for that negative. It's 14. 14. All right. So then we have negative 18 over 14. I see those are both even numbers. So negative 18 divided by 2 is negative 9. 14 divided by 2 is a positive 7. Whoa, whoa, whoa. Look at that. They're all the same. So are they all going to be on the same line? The answer is heck yeah. You did it. Okay, and why? How do we know? Because all the slopes are the same. It's exciting. All right, next page. Now this page gets a little crazy. Who knows what we're doing here? All right, so if you know a line has a slope of 1/3 and it goes to the point 7, 5. So it's important to remember about that 7, 5. 7 is the x, 5 is the y. Okay, we're going to find 3 other points on the line. So when we do our coordinate plane here, when we do our slope formula, we know we have 7, 5, and then we're looking for 2 other numbers. So we have our x, y, x, y. So let's think, what minus 5, so what y here minus 5 would give me 1? Well, 6 minus 5 is 1. Okay, and that's my y, so that's going to be my 6 here. Now I'm thinking, what minus 7 is 3? My brain works too fast, and I think 4 minus 7 is 3. But 4 minus 7 is negative 3. So to make a positive 3, we need a bigger number than 7. So that would be 10 minus 7 is 3. So my y is 10. Not my y, my x. All right, so 10, 6 is also on that line. So here's your hint. What other slopes could be equal to 1/3? Well, when we take 1/3, we could multiply that top and bottom by a number. So 1/3 times, and then you just literally pick any number. So let's do 2. So 1 times 2 is 2. 3 times 2 is 6. So this time I want my slope to equal 2, 6. And I'm going to set it up the same way. So I'm thinking, what number minus 5 equals 2? Okay, and since it's a positive 2, I know it's going to be a bigger number than 5, so that's going to be a positive 7. Okay, now what's hard is to remember that that's actually my y. It's goofy. 7, y. Okay, on the bottom is the x's. So on the x's, we have, I did that in the wrong color. Oh, minus 7 equals 6. So a bigger number than 7, that equals 6. So that would be 13, I think. 13 minus 7, yeah, is 6. Okay, so we have 13, 7 is also on that line. Okay, now we don't have to think too much harder for this one. We can just kind of flip this around. So instead of doing something minus 5, we could do 5 minus something. And I want that top to equal 1. And on the bottom, I want it to equal 3. Or I could do 2 and 6. That's fine too. So 5 minus 4 is 1. So that's my y. Again, I flipped those colors. Okay, and then on the bottom, I'm thinking 7 minus what is 3? 7 minus 4 is 3. Whoa, we get the same number, 4, 4. And I made them both red. All right, last part here. If we know a line has a slope of m and goes through the points x1, xy, and x1, y1, okay, we know that we could use our slope formula. Okay, so we could take y minus that y1 over, so we subtract the y's. If I start with this y, we're going to start with this x. So x minus x1. And that's going to equal our slope. And here our slope is m. Here's something cool, is that we can get rid of this dividing by multiplying. So it's like these guys are hanging out together on the bottom. So to undo dividing, we're going to multiply both sides by x minus x1. Multiply by x minus x1. So the x's are gone. We'd be left with y minus y1 equals m. And then I don't need to write times. I can just go that parenthesis x minus x1. Now this, many mathematicians realize, is point-slope form. Point-slope form. Okay, and in point-slope form, the 3 parts that we have is y1 and x1. Those are going to be numbers. And this m is going to be a handy-dandy number. Sure fancy. Okay, so here we go. This is our slope. You can color these in, fun colors if you'd like to. M stands for slope. And our x1 and y here stand for an ordered pair. And what always comes first? First is the x1 and then the y1. Okay, so that is a point, hence the name point slope form. That does not look like an exclamation point. Alright, so we're just going to do a quick few examples. So in this one, we're going to identify the point and the slope of each of the following lines. So underneath this, I'm going to write y minus y1 equals m times the quantity of x minus x1. So the question is first is the point. So the point is this x1 and y1. Okay, and notice it says minus here. So since it says minus 2 and minus 3, that means that it's actually just going to be 3 and 2. So our point is, what are we subtracting? We're subtracting 3, so it's positive 3. And here we're subtracting 2, so it's a positive 2. And our slope is our m, which generally people are really good at finding because it's just whatever's on the outside of the parentheses. And that's 3/4. So we're done. We're rock stars. Life is good. This is messy. All right, here we go. Y minus y1 equals m times the quantity of x minus x1. So we're going to start with the point. The point is the x1. Switching colors. x1 and y1. When we write our point this time, my x is 1, and it says minus 1, so that's good to go. But this time it switched. It went from an opposite. It went from a minus, and the opposite of minus is plus. So we have to think the opposite of 6. So the opposite of positive 6 is negative 6. Wah, wah, wah. Okay, so it's kind of confusing because it's opposite of what we normally think. Normally we think if this is a plus, it would be a positive. But in point slope form, when it's a positive, we actually have to do the opposite and make it a negative. If it's a minus, that actually means it's a positive. Okay, and then our m is this handy dandy -4. Easy peasy. Slope is so easy. Alright, now we have this equation y minus 7 equals 2/5 x. So we're going to write y minus y1 equals m times quantity of x minus x1. What? There's no x1. Okay, so what we're going to do is we're going to make an x1. We're going to say minus, what number could I subtract that doesn't change x? The number I can always subtract that doesn't change things is 0. Handy dandy 0. Okay, so my point is x1, y1. So my x1, the number I'm subtracting is 0, and it was a minus. We could make it a plus, but the opposite of 0 is 0. There is no opposite, or it's the opposite of itself. And then y1 is 7, and the minus stayed. It said minus 7, so we don't need to worry about changing anything. We just say 7. Okay, slope is that handy dandy number on the outside of the parentheses, which is 2/5. All right, last one. I suggest pausing it and trying it yourself, and then seeing if you have it right. Okay, so y minus y1 equals m times the quantity of x minus x1. So my point is the x1, y1. We just need to check to see if anything changed to make the opposites. So my x1 is 8, but it changed from a minus to a plus. So that would change opposite, so I actually want -8, because that's the opposite. And then my y1 is 9, and it stayed a minus, so I don't need to do the opposite, just stays 9. And then we get the easy peasy slope. Slope, slopey, slope. Slope, slope, slope. -1/3. And that is it for this handy dandy video. Point slope form. It's so great.